All right. Hey, everybody. It is really good to see you all and to be here. I am Hazel Weekly, and I am the infrastructure witch of Hachyderm. And I'm here with my co-presenter and co-worker, friend, colleague, etc., Preston.
Yeah, and I'm Preston Doster. During the day, I work for Twilio as an architect. When I'm not doing architecty type stuff, I'm the current infrastructure lead for Hachyderm.
Awesome. So as a quick beginning question, this is generated by AI art, as is, I believe, the trend. Feel free to try and read it if you can't. Does anyone here watch birds? Do you use the bird app? Are you part of the bird app watching community? Anyone here? Raise your hand. Nice, nice. Good to see you all. How about, did anyone migrate from bird watching and join a local elephant community around you? Oh, I see actually about even number of hands. Very nice. Some of you raised your hand twice. That works, that works. Well, so we also moved from bird watching into elephant migrations. And so what we're going to talk about today is how Hachyderm kind of accidentally became one of the largest elephant watching sanctuaries out there, and some of the challenges that we faced in undertaking the great elephant migration. And now that we've done that, what is next? And before we dive into that, I am actually really curious, of those of you who have joined an elephant watching community, how many of you picked Hachyderm? Ooh, I like it. See a lot of hands here. Were any of you around for this incident when we migrated out of Nova's basement? Yeah? Well, you weren't around because you couldn't log in. But good to see you. Good to see you. And hopefully you understand things a bit more from our perspective now. All right. So I'm actually going to spoil the punchline because I think Hachyderm is a stunningly good example of why root cause analysis is useless and why you should never do anything with it. So the root cause was we had 2 failing hard drives. So boring, right? Useless, absolutely useless. The perfect hindsight solution, here's how we could have avoided the entire thing of pain, the entire whatever, everything. Here's how to solve everything. If you do this, your production environment will never break. If you just use the correct thing and you don't run NFS transatlantic, and you see the impending doom, have a time machine, and then do all your migration a week before it happens, everything's great. But if you can't do that, then you're going to run into this migration. And so that's what we did because we don't have a time machine. So it also turns out that even if we had solved that one issue, there's what I like to call, the time loop paradox of distributed systems. If you go back in time with that time machine, do you actually prevent all the problems? No, because you go back, you save the person, and then they get run over by a different bus. You can't fix it. You can't save it. You can't whatever. You have to suffer a different, more fucked up solution. So it's inevitable, right? It's inevitable. And so we found ourselves stuck in the middle of that inevitable thing. Systems resilience requires systemic adaptation, and any sort of trying to solve one particular insight or one particular problem will solve that one. The system is a healthy, growing organism that involves technical people, social things, all of these coming together, and that's what is really needed. If you want to solve a system and solve everything, you can take all of the work in SRE, all of the work in distributed systems, everything, you can boil it down to 3 words. Make change easy. You can go home now. That's the whole talk. That's everything you'll ever need to know about doing a DevOps, being an SRE, building a resilient system. If you want to recreate AWS, all you have to do, make change easy. That's the whole thing. Everything everyone will ever talk about, it's right up in there. But making change easy is not the same thing as, making change easy to handle. It's not the same thing as making change easy to do. You want to make change easy to handle, But if you make change easy to do, what you're going to do is you're going to end up in a situation in which you're not ensuring that you can think about and reason through that change. And so you'll see a bit more of like this popping up later in the incident. So getting into the great elephant migration, now that I have spoiled the punchline. The old habitat that the elephants were in before we did the migration was a bit janky. We had an experimental ZFS on everything. The kernel had a bunch of debugging symbols turned on, some weird experimental flags, and Nova was using this kernel on her local machines to test root exploits. And Mastodon was also serving all of its media off of NFS, which was fine until it wasn't. And the main single machine had Mastodon, Nginx, Kubernetes, Postgres, and Redis all running. We had a couple other machines also running most of that. So single-purpose machine, more like single-purpose universe with, yeah. So that was the old habitat. And it worked actually pretty great right up until, you know, the birdocalypse happened and everyone started saying, maybe we need to be elephants. And so we saw this happening. We saw it. We saw the whole thing happening. We saw people coming in. We went from like 700-ish people on Hachyderm to 6,000 in 10 days. And then we went to 25,000 in 7 more days after that. So we had achieved the dream, the glory, exponential growth. So we had seen this coming. We decided, let's start building a V2 for Hachyderm, something that's not in Nova's basement, because it has now become production, and it cannot be a playground. We need a real production environment. A couple days after that, this is the first inkling that something's really wrong. While we're building out the V2 happy and merry, NFS became unusable, and it was locking up for 30 seconds at a time. So we're like, interesting. Let's dig into that. And so we had this pull request. We had opened up, NixOS is the future. We're going to switch to that. Everything's fine. And then we ran into this problem, which is not ideal. It turns out that when your system is sad, sometimes it loses all of its motivation to do anything and just sits there and locks the file system up for 30 seconds or so. And if that happens, but the file system really needs to be used by all the other things that are using it, they just kind of knock on the bedroom door to go, hey, are you there? And it's just sad, and that's not great. So I'm like, this is curious, because things are kind of working, but also kind of not. They're flip-flopping between usable and not usable. And so when trying to debug this, trying to investigate this, that we're still in the first 2 days of the breakage, I accidentally wrote the largest and most comprehensive notes on scaling Mastodon on the internet. I didn't intend to. It's just that no one actually wrote down how to fix anything. And so you had this open source software thing that had no real telemetry, no real observability, no real metrics, no real anything. And all of the knowledge was cultic knowledge. So I was going through GitHub pull requests, GitHub merge comments, random things people have posted in Slack messages, random things people have posted in like archived IRC channels, gists, little hacker note things, MD documents, random web blogs, a mailing list from 2005. Literally a mailing list where someone's anyway, everywhere, absolutely everywhere. We had gotten the system kind of stable a couple days in, and we're trying to figure out like why is it actually not quite getting there. And the only way we were able to get it stable was by running the queues slow enough that we were processing things slower than we were ingesting data. And so in order to scale up the compute, we were like, we need to have more CPU, more things like that. Let's take all of our stuff that we were running in Nova's basement and run some of it in Nova's basement and some of it in EU. Spoiler alert, we're still running NFS. So we had this cycle of toil. Step 1, error points up. They're going to balance the sidekick queues manually because they need to. Because things, they break, you jack things up, that gets stable, this other thing breaks. It's like you're playing, table balancing or like this spinning thing, but with sidekick queues. And then the US wakes up, and I wake up and I get to see how fucked up the queues have gotten. We're running 50 instances of this, and it should be only 2. We're running 20 instances of this, and it should be that. And we're just kind of doing this. And I go, well, based on the system that we have, the hardware, here's where things should be. And then we're both wrong. And we just do that over and over. And finally, we get really sick and tired of being wrong. As SREs, we don't like to be wrong. We don't like a system in which, knowing everything we know, everyone agrees with us. 1 plus 1 is 2, right? Everyone agrees. And then 1 plus 2 is 17. That really bugs you when someone says that. So we're like, all right, we have not actually really solved things. We're not getting anywhere. Yeah. How we broke this toil cycle was we actually did this thing where we introduced manual changes in production. Anything that we had to do, because we're still SSHing in, you had to log it via a PR. And then we had scripts to explicitly list everything required. But earlier in the talk I said make change easy, and this seems like the opposite of that. This seems like adding a bunch of unnecessary friction. Seems kind of not making change easy. You want to make change easy, but by redistributing friction into key areas, you balance human workflows and you streamline communication. Because it's not about making it easy to change things, it's making change easy to process. And humans need time to process, they need room to process, they need back pressure, circuit breakers, all of these fun things that you put in your technical systems. Socio-technical systems need to tune on both ends, just like they also need the social parts on both ends. Everything is together. And so it's really important to make sure that your humans have back pressure and your servers have cute little names. Oh God, I pressed the wrong button. There you go, perfect. One more. We then decided, after we had started to get an inkling of what's actually happening, the quote, root cause, so to speak, we're like, all right, we need to start reducing some pressure on the file system. Let's move to object storage and literally taking our logs and putting them in RAM. Don't log to the file system, log into RAM. We had spare RAM. That wasn't a problem. So don't make file system calls. Awesome, easy, right? And we need to move the database out of Nova's basement because it's really slow for some reason. We hadn't gotten to the reason, we're like, this is really slow. So let's move the database over. When we did that, it turns out that if you want to make Postgres hate you when you're doing things, you can follow this really easy formula. You can say, oh, hey, things are really slow. Add more workers, which adds contention to Postgres, connections to Postgres, and slows it down. Not using the open connections, by the way, literally just having a massive amount of connections available in Postgres can make some queries up to 45% slower. Which then means the Postgres is going to do a lot more I/O because more things are open in flight. They're just not doing anything. Your queries are then going to take too long. You're going to run out of connections. You're going to go, we need more connections. And then you bump the limit up again. And then you go over 9,000, and that's actually really bad. Don't do that. But at this point in time, we have bumped the limit up twice, and we were running 4,098 max connections in Postgres. And it turns out, for internet scale databases, they still recommend literally never going above 1024. Enter, never going to need more than a gig. Never going to need more than 1,000 connections. It's actually pretty all right. And this is where we started to really put the pieces together. We're like, all right, so the same server, the same file system. We're starting a database transaction. we're uploading an image to NFS. You insert or update the statement, and then you commit to the transaction and close the connection. So you hit the file system, you lock up the database, and then you touch things, and then you close the call, and you do all of that. So this is how you get those interesting interdependencies between things. Because even if the database is in RAM, even if a bunch of other things are like in RAM, we're reducing the amount of system calls for files and things like that. We weren't. We were just shifting it into a place where we couldn't see it. Speaking of slow system calls, how many IOPS do you think it takes to run a distributed system? Give me a number. I know you're going to say it depends, but that's bullshit. I want a number. Give me a number. It turns out that whatever number you're thinking of is probably a lot more than we had. So we had 312 f-syncs per second, which is, I believe, about the same as an SD card from 2004. And so if you take your Raspberry Pi, you too could run a single Mastodon instance and serve 30,000 people off of it. Or, you can't, because we definitely were not able to do that with this. But an SD card, surprisingly also slow, but so are our hard drives, which are all solid state. Everything was solid state. This is a small number. So, okay, this is where we really realized, we hadn't figured out the hard drives maybe failed yet. We just knew it was really, really slow. We have run into a situation that database admins would mostly call suboptimal. And then on top of that, we were running NFS transatlantic because we had successfully migrated everything but the database to Europe. The database, of course, and all the files are still stored on the same machine. And that machine, we finally found out, had 2 failing solid-state drives. So why didn't we notice this earlier? We had no idea what we were doing. And it's kind of all right. Because if you know what you're doing, you know what you're doing for that one thing, and something's going to come up and you just don't really know all of the missing pieces, you don't know all of the puzzle things, and that's okay. And we had metrics, we had data. They're only as good as your ability to understand the system, and most systems are actually, by definition, not understandable. And no one thing was ever obviously wrong. It's like when we saw the 300 IOPS, when we saw this and that. Is that because the file system is only capable of it? Or is that because we're only requesting that much? You still can't really narrow anything down, even if you have other pieces. Maybe you can't put them together coherently. It's only when you have that whole systemic approach to trying to understand the system that you can get into, okay, maybe I can form this hypothesis and start testing it. So why didn't we take this approach to the migration? Because if you notice, it took us about a week, and we did actually make this harder for ourselves. We could have solved it maybe by having cloud scaling systems, by using managed services, by having other people, not us, care about it. Run less software is a very good idea. Everyone likes to say that. We were running all of it. We did want to build a community that was for the community and something that was meaningfully owned and operated and believed in by the community. We had just been through a very traumatic breakup with the bird watching community, and the idea that this new community was going to move to a new place and go through the same exact problem of now it's just a different dictator, but this one is cuter or funner, more hilarious. I don't know. That's not really actually solve a thing. So we're really interested in how can you actually build a thing that other people can take part in. And so one of the things we tried first was, what if we all own the hardware? That didn't quite work for the timeline that we had. So we moved to maybe if it's just not beholden to corporate interests, let's try that out. And that sort of flexibility of like, we're trying to solve this thing. We imposed a lot of constraints on ourselves that did make it harder to solve this problem. We also sort of burned out because this was a week-long incident. It was very much a death march type of thing. It was very much, some of us were taking our laptops to bed. Some of us only slept 4 hours a night. This is the definition of something that you'll see in books, and half the team quit after. Or you'll see it in like war stories, or like horror things of like, and then no one ever wanted to work for that company again. They died, they failed, and you never heard of Xerox again. So why did we actually not burn out? Well, so we had this intrinsic versus extrinsic motivation issue here of something fundamentally changes when you sign up for something voluntarily. And it's very hard to replicate that in a corporate environment, and you have to take that into account. If you give someone a paycheck and say, I make you care about this problem, the dynamics change, and you can't get away from that. But some things that are kind of the same or are also equally difficult to replicate is the aligned incentive throughout the process. Like when we made the problem harder for ourselves, we chose that. We sat down before the incident, really got into high gear, and we were like, all right, do we solve this by just solving it? Do we give up, take the easy way out, upload everything to S3 and RDS and call it a day? And we all said no. But we chose that. And a lot of times at companies or a lot of times in like more corporate interest and things like that, you're not allowed to like opt into your own situation. And that can be very discouraging, that can be very frustrating, it can cause a lot of damage. Speaking of damage, we had this intense amount of psychological safety. People could bring up anything, absolutely anything. And it will be valued, it will be trusted. We had people that are world experts in their domain going, I'm pretty sure this, but maybe not. And we have people that knew nothing about that same domain, and they went, maybe not, maybe this other thing. And we were treated as equals, and that was really important. And like I said, we did choose our own solution. We chose its downsides. We signed up for everything, and we always had the ability to opt out and do something else. We had the ability to adapt if we wanted to, and so we had that going in. And of course, we continually supported each other throughout the entire time. We sent each other memes. We would tell each other to go off the computer. We'd say, oh, hey, you need a break. I can tell you, dude, you're tired. Go take a break. Sometimes we made each other take breaks. We really looked after each other as much as we were looking after these systems that we were caring for. So you will never be prepared for exponential scale, but you can be prepared to support each other through the challenges you'll face. And if you take things, bring them together, along with the people, the technology, the process, the whole ecosystem, and make it more about how do we handle change, how to be prepared for it. If you know you're never going to be prepared for a certain thing, you can be prepared to support each other. You can be prepared to adapt, to be resilient. All of these things, it really comes down to how can you work together and get better at that. In conclusion, operating a Mastodon instance is great. It has all the reliability and ease of maintenance of a Rails application, the user experience of hosting a mail server, and the developer workflow of date drinking on the Linux kernel mailing list. It is fantastic. Recommend it. Don't do it. And Preston here is going to be telling us, what's next.
Yeah, totally. So it's always fun, reliving all that history and just remembering all the fun we had. I don't know if I trust this thing. I'm gonna.
We'll try it out. I'll support you.
Fail over to the laptop, I think.
Fail over.
But yeah, so obviously, the team did an amazing job getting us to where we are today. a lot of hard work has gone in, and we've built some really great bonds. But the reality of something like a Mastodon server is that it keeps growing, right? People keep tweeting, people keep posting images, like it keeps growing, right? So we can't stay still. We can't just operate the thing. We have to keep growing and figure out, okay, where are we gonna head next? And today, like where we've landed, this is stats of just a little bit recently, we're about 20,000 monthly active users. That's super cool. Like for something that started from like a handful of folks, like knowing that there are people who use this daily and who love it daily and interact with it daily is awesome, right? That's super cool. So there are 20,000 people out there that are regularly using Hachyderm. It's stateful, right? We can't just delete the thing and say, hey, oops, we lost the database, or oops, we lost the media server. People care about that stuff. It's also real time, right? Like if there are any blips, right? If we have really long latency for some reason, people notice, people post, right? So again, we're having to constantly watch this thing and take care of it as it grows. Ultimately, though, our key constraint, Hazel started to hit on it a little bit, is we have volunteers. This is all opt-in. We aren't paying anybody. These are people who do this because they want to do it. Maybe because they want to learn some technologies, learn some SRE practices, but this is all voluntary. And that volunteer time is super limited, right? On a really great week, maybe 2 hours, 3 hours a week a person, right, to get stuff done. And if you think about our day jobs where normally you have 40 hours a week, how do you get through a backlog when you're getting 2 hours a week from a person, right, from a handful of folks? It can be fun and interesting. And ultimately what this really leads us towards is we have to be really judicious with our time. Like when we spend time on the infrastructure, we need to make sure we're spending time on the right stuff. There is a really great, like one of my favorite talks by Brian Cantrell, Platforms is a Reflection of Values. If you haven't seen it, definitely recommend that you do. Ultimately, he talks a lot about how platforms choose the values or need to choose the values and be very intentful about how they choose the values of their platform, because that then ultimately helps you choose your technology choices. Like what things do you bring into your stack? Kind of like Liz was saying earlier with like Kafka, right? Key component, very important, right? But then ultimately it also helps you understand how you need to prioritize your time. Again, 2 hours a week, you don't get a whole lot of time. You got to make the right choices. So as Hachyderm, what do we value as a platform team or as an infrastructure team? So first and foremost, approachability, right? So Mastodon itself is somewhat unwieldy. It's grown over time. But again, with that limited amount of time that we have with your volunteers, you want to make sure there's a low barrier to entry. You want people to be able to say, hey, I want to volunteer, and show up and be able to contribute code or contribute changes or improvements to the infrastructure relatively quickly, right? So that's where approachability is key. People need to be able to walk up and go, oh, hey, I understand what's happening here. We also want to be open to all backgrounds and levels, right? All types of folks, so that we don't need staff, a team of pure staff engineers. We want some people who are maybe in university right now, maybe just getting interested in tech, right? Maybe don't have a comp sci background. Again, we want you to be able to walk up and contribute and add. And again, really this comes down to how do our volunteers use their time effectively, right? We don't want folks to be like looking at the infrastructure set going, oh, I just don't know what the heck is going on. I can't contribute, right? We want to be really effective with that time. And part of that is also safety. Like, again, SREcon is all about safety. How do we ship safely to production rapidly and over time and make sure we don't break things? Ultimately, this also helps us encourage experimentation and growth, right? Because, like Hazel said, we don't know all the answers, right? There are lots of emergent properties of distributed systems. And the next time there's a big migration off of the bird site, maybe we need some of this experimentation to be ready for those types of things, for those really critical events. The other key thing, in building psychological safety is we want to make sure that people know it's okay to break prod. It's going to happen. It is inevitable. Like Hachyderm at some point will go down or be degraded. It's okay, right? But we want to learn from it when we do. Right? If we haven't learned from it, then maybe it's not so okay. So we always need to go figure out, okay, hey, what when we do that incident analysis, what happened? What can we learn? How can we do better? How can we build around this? And then also key is just making sure that everyone knows we're in it together, right? So there might be a week where maybe I have a lot of extra time, so I'm spending more time, but then we end up in an incident, but I can call Hazel, or I can call Nova, or I can call anybody on the team and be like, hey, I need some help, right? Nobody's ever in it alone, even if the site's down, right? It's nobody's fault. We all go make it work together as a team. And then lastly, transparency is really important, right? And transparency actually helps build some of that approachability and safety as well, right? No hidden agendas, right? Nobody's out here to, I don't know, do something with the infrastructure or push a particular product or anything like that. We're here to make Hachyderm work, right? And part of just making sure there's transparency is writing things down, right? It's just documentation is key, which again, we all know in our professional lives, like sometimes it's hard to get documentation and get people to write good, effective, meaningful things for others to read. But in a volunteer situation, it's even more critical, right? Because let's say I'm on vacation or I'm giving a talk at SREcon and I'm not available, and I'm the person who set up the certificate rotations, and we need to rotate a cert, right? That needs to be written down somewhere so that, again, infrastructure becomes approachable. It's easy for people to walk up and understand and do what they need to go do. And then third, this is something that we're building our muscles around, clear team backlog. Right? Again, as part of being an effective volunteer team, we can't always say, hey, let's have a daily stand-up for 15 minutes. Right? If you actually look at our infrastructure team, very geodiverse. We have folks in the US, we have folks in Asia, we have folks in Europe. There is no common time for us to have a sprint planning session. It's just not a thing that we can do, right? So you leveraging that team backlog and just being very clear, here's the next milestone, here's the next goal, here's what we're after. Let people walk up and know, hey, here's a good first issue, right? If you've been away for a while, go pick this, right? And then finally, y'all have seen this if you've been active on Hachyderm, we do public incident reviews. So anytime something breaks, we do a pretty good job of doing an incident review, talking about things about, like contributing causes, talking about next steps and how we're gonna go improve over time, and then posting that, right? And allowing for community feedback as well. So always sharing, again. And the idea there is we don't know everything, right? So we use the incident process to tease some of those things that we didn't know during the incident out. And then we also sometimes look at the community and say like, hey, I know something about ZFS or whatever, right? And they can go contribute to even making Hachyderm better as well. So again, all those values really wrap up and then help us start to choose some of these technology pieces that we want to do going forward. And some key choices that we're starting to look at. So NixOS is one of them. So we've mentioned Arch as kind of our current operating system, but we're looking at NixOS as our base OS and really operating environment. If you look at the NixOS website, so I'm actually super new to NixOS. I know almost nothing about it. I'm learning a whole lot from Hazel, which is awesome. But it's reproducible, it's declarative, it's reliable, right? And if you look at the SRE journey over the last X years, right, those are values that ring true for SRE folks and for DevOps folks, right? It's all about reliability and how do you get the same thing out every time you run the thing, right? And that's what NixOS really strives to do. And this really hits home on our safety and approachability goals, right? Safety because, again, for a volunteer, if they go rebuild their NixOS machine that they're working on, they know exactly what they're gonna get, right? There will be no surprises. And approachable, and I put a little asterisk on there because I'm still learning myself, still figuring out NixOS, is once there's a good base there, it's actually really, really easy to make operating system level changes and roll them out. So I have an example here of a PR that I did. What was I doing? I was improving our backup procedures for the main database. And I'd accidentally built a Postgres 11 system. I deployed it out there, got my, downloaded all my backups and everything. I was about to restore. I was like, oh, wait, we actually run 14 on Mastodon. So oops. So, but literally like with one line change or with one character change, I go redeploy and I have a Postgres 14 box. Like super simple, like minutes later, right? So I'm warming up to NixOS. And again, I think it's one of our big bets around that safety and approachability value. Hazel started talking about this a lot, was multi-cloud. Right? So we are not in AWS, we are not in Azure, we're not in Google Cloud, and we're actually using a lot of different clouds, which actually sounds a little funky, right? Because you might say, oh, well, multi-cloud, that's hard. Right? At work, we talk about multi-cloud a lot, and it's always like, yeah, we'll do that in Q5, right? So we'll do it later. But we started with multi-cloud from day one. So we have presence in Hetzna and Linode, or Linode, depending on how you like to say it, DigitalOcean, and at one point, yes, Nova's basement, still a little bit there. And it's kind of this paradox because you would think it would make things more complex, but we actually start to weave things together, and I'm actually going to skip this slide really quick and we'll go back. We weave stuff together with Terraform Cloud. So again, you see some words that I mentioned earlier about NixOS, right? Terraform is declarative, it's reproducible, it's reliable, and we actually use that to span all the different clouds, right? So instead of having a volunteer show up and go like, oh, do I need to log into Hetzna or to Linode, or do I need to log into DigitalOcean? The answer is, oh, no, you go use Terraform Cloud and you go weave Terraform to go affect change to the world. Now, do we still have to log into those different portals occasionally? Yeah, sometimes. But the majority of the infrastructure work now happens through Terraform and through NixOS. And again, the idea here is it lowers that barrier to manage the infrastructure, right? You can easily walk in, and if you have access to our infrastructure code base, you can go look at the Terraform, right? And you can see where DNS is, you can see where the virtual machines are, you can see where the S3 buckets are. And ultimately, and again, around building safety and approachability, we get to a very predictable workflow, right? And the workflow is, you go edit a file, you go do a PR, you go see the result of the plan, and you go apply it, right? So you get in this kind of cycle here, where, again, all engineers here, I'm pretty sure, are familiar with Git and the PR cycle, right? So, and key is elevating any kind of issues that you're gonna have really early on, like way before you actually go apply it, so you get a nice check on your PR, and you know exactly what's gonna happen. So in this case, I was blowing some stuff up on purpose, and it makes it not scary to do it, because I knew way before exactly what was gonna happen, right? And then lastly, I've talked a lot about transparency and making sure that things are written down. Again, because we only get those 1 or 2 hours a week from folks, something's better than nothing, right? It doesn't have to be the perfect documentation, does not have to be perfectly formatted, doesn't have to be completely thorough, but we do need something, right? We do need enough so that, like Hazel said, when she went digging through the history of Mastodon, she was able to pull out enough stuff to go move forward. Same for our infrastructure as well. Obviously, we want it to improve over time, but something, right? And we look for things like good PR comments, right? Things that express why you're making the change you're making. Because obviously the code says what you're doing. Why are you doing it? Like, why did you need to go affect this change in the infrastructure? Good issue descriptions, again. So when we're building that backlog, why am I doing the thing that I'm doing? What do I need to go do? So you have clear, approachable backlogs that you can go reference. And then markdown docs in our repo too, right? Including things like our incident reviews, our incident analyses, architecture diagrams, and really anything the next human can use, right? So that if I've been on vacation for 2 weeks, which I have, and I come back, I know what's changed, right? I can go look at the PR feed, I can go look at the documentation, I can go understand what's happened. And this is an example of an incident review that we did. This was actually funny enough, a pretty simple one. It did take the whole site down for about 30 minutes. We didn't pay a bill, right? And the theme that we've heard from a lot of folks, and that you'll hear, I think, all throughout the week, is there is no root cause, right? So yeah, technically I could say, yes, the root cause or the immediate cause or the major cause or whatever you want to call it was that we didn't pay the bill. But the reality is there's a bunch of stuff behind that led to that moment, and that contributed to that moment. So like ultimately it was like, I think it was like in Hetzna Cloud, if you use PayPal, you have to go in and mash pay the bill, right? When you would expect, hey, you just take my money, right? Like just keep paying the bill, right? So, but that led into a lot of other areas like, hey, we needed to write down some billing documentation, right? Like nobody actually knew how we were paying for things because somebody set it up because we're moving really fast, which is expected, right? And we want that freedom and flexibility. But this is a great example of, hey, it's okay, prod was down. It's all right. We learned from it, we wrote it down, the next people can go learn from it, and the service is going to be more stable for it. So with that, questions? We've got about like 3 minutes or so.